Whenever a missile attack targets Israel, the country's air defense systems inevitably take center stage in global headlines. However, most people recognize the Iron Dome for its ability to intercept incoming missiles. The system indeed has a rather catchy name, but in reality, it's just one component in a much more sophisticated network. To fully grasp how Israel's air defense systems function, it's crucial to first understand the concept of a multi-layered air defense system. A multi-layered integrated air defense system, or IADS, is a sophisticated defense architecture designed to protect a country or region from a variety of aerial threats, including aircraft, drones, cruise missiles, and ballistic missiles. IADS is organized in a way that different systems work in harmony, providing an overlapping defense. This layered approach ensures that even if one layer fails to intercept a threat, another layer can engage it. The system is designed with multiple redundancies to maximize its chances of successfully neutralizing a threat. Each layer is supported by independent detection and tracking capabilities, but they share information in real time through a centralized command structure. This allows for seamless handover of tracking responsibilities and ensures that all threats are monitored continuously as they move through different zones of the defense network. A central component of IADS is the command and control system, which integrates all the data from sensors and radars, processes it in real time, and directs interceptors toward targets. This system, often enhanced with artificial intelligence, ensures a coordinated response across the entire defense network. IADS typically consists of several layers, each responsible for handling different types of threats based on range and altitude. Early warning and detection systems are the eyes of the defense system, often consisting of long-range radars and satellite-based sensors. They detect incoming threats early, providing critical data about the target's location, speed, and trajectory. Systems like the RAT-31DLM long-range radar can provide 360-degree coverage for detecting aircraft, missiles, and drones. Short-range systems focus on intercepting low-flying, short-range threats like drones or cruise missiles. They are particularly useful for defending against threats in close proximity to critical assets. Medium-range systems target medium-range threats, like enemy fighter jets or medium-range ballistic missiles. They bridge the gap between short and long-range defenses, providing a secondary line of defense if short-range systems fail. Long-range systems intercept ballistic missile and high-altitude threats before they can reach critical infrastructure. Target selection and engagement. One of the most important aspects of an IADS is how it selects and prioritizes targets. The Command and Control, or C4I, system uses advanced algorithms to evaluate threats based on their trajectory, speed, and potential impact on critical assets. For example, a ballistic missile headed towards a densely populated area would be prioritized over a drone in a remote region. The system assigns interceptors from the appropriate layer based on the nature and proximity of the threat. Modern IADS can also handle saturation attacks, where multiple threats are launched simultaneously. The command and control system coordinates the responses from various layers, ensuring that no target is left unengaged. This process happens in near real time, leveraging networked sensors and fast-response missile systems. Now that we've given you a solid understanding of how an integrated air defense system is structured, let's dive into how this doctrine is applied specifically in Israel. Iron Dome. For short-range air defense, Israel relies on the Iron Dome. Its ability to detect, analyze, and intercept multiple targets at once makes it indispensable for defending against the frequent barrage of short-range threats faced by Israel. The Iron Dome's advanced radar and targeting systems allow it to differentiate between threats heading toward critical infrastructure and those that pose no risk, prioritizing interceptions accordingly. This ensures efficient use of interceptors, preserving resources while maintaining robust protection for civilian areas. The Iron Dome platform is an air and missile defense platform developed by Israel's Rafael and commissioned by the government. It's a dual-mission system that provides an effective defense solution against rockets, artillery, and mortars, as well as aircraft, helicopters, unmanned aerial vehicles, and PGMs. Iron Dome batteries can detect and intercept rockets and artillery shells headed for population centers within a 43.4-mile range, using a detection system to determine if a trajectory of an enemy rocket poses a threat. They launch Tamir missiles to intercept targets, and each battery can hold 20 missiles at a time. Each battery is estimated to cost as much as $50 million, plus maintenance and manpower costs. Many estimates for the cost of Tamir interceptors are around $40,000 to $50,000, but an American Army missile budget listed each unit at around $163,000. The system is widely regarded as one of the best in the world. Estimating the scorecard is difficult, especially when not all the figures are available. Despite over 4,360 projectiles fired at Israel, Iron Dome maintained its 90% interception rate. And it is not a cheap system at all. Usually, a single Tamir missile is launched per interception. But multiple Tamirs are launched for each interception to kill heavier rockets. This means an interception could cost more than the price of a single Tamir missile, which is already a very expensive countermeasure for a low-cost projectile. To counter this, Israel has a very innovative solution to integrate into Iron Dome: the Iron Beam system, a prototype of which was unveiled last year, uses lasers to superheat and disable aerial threats. The system is most effective against short-range threats such as rockets, mortars, drones, and anti-tank missiles. According to Israeli officials, the Iron Beam's interceptions are silent, they're invisible, and they only cost around $3.50. David Sling is a medium to long-range air defense system that plays a critical role in Israel's multi-layered missile defense network. Developed jointly by Israel's Rafael Advanced Defense Systems and the US company Raytheon, it was designed to counter a wide variety of aerial threats, including ballistic missiles, cruise missiles, and large-caliber rockets. David Sling fills the gap between the short-range Iron Dome and the long-range Arrow systems, offering protection against threats that fall within a range of 40 to 300 kilometers. The key component of David's Sling is the Stunner missile, a highly advanced interceptor designed for maximum precision. The system uses a hit-to-kill mechanism, meaning the missile directly collides with its target to destroy it, minimizing the chance of collateral damage. The launcher unit, called the Transporter Erector Launcher, or TEL, is capable of holding between 6 and 12 Stunner missiles, which are stored vertically for rapid launch. The multi-mission radar and command and control systems are integral to tracking incoming threats and guiding interceptors with high accuracy. The system's radar and control units are crucial for detecting incoming threats, determining their trajectories, and selecting appropriate targets. The multi-mission radar tracks multiple targets simultaneously, and the command system prioritizes the most dangerous ones based on their trajectory and potential impact. Once a threat is identified, the stunner missile is launched to intercept it in the final phase of flight, ensuring minimal risk to civilian areas or military installations. This hit-to-kill approach offers precision not only against direct ballistic threats, but also fast-moving cruise missiles. Perhaps the crown jewel of Israel's air defense is its formidable long-range layer, the renowned Arrow systems. The Arrow system works as the upper tier in Israel's layered defense network. As we have mentioned previously in this video, while systems like Iron Dome and David Sling handle short and medium-range threats, Arrow 2 and Arrow 3 are designed to protect against long-range ballistic missiles. The Arrow air defense system is a cornerstone of Israel's multi-layered missile defense network, developed to provide protection against long-range ballistic missile threats. Jointly developed by Israel Aerospace Industries, or IAI, and Boeing, with significant funding from the United States, the Arrow system plays a key role in defending Israel from advanced missile threats, especially those originating from adversaries like Iran. The Arrow family consists of two operational layers, Arrow 2 and Arrow 3, each designed to target different stages of a ballistic missile's flight trajectory. The Arrow Weapons System, or AWS, includes several key components. The Arrow 2 intercepts ballistic missiles within the atmosphere, targeting the missile during its mid-flight phase. The interceptor uses a fragmentation warhead to destroy incoming missiles and has a range of around 90 kilometers with a 50-kilometer altitude ceiling. The more advanced Arrow 3 operates outside of the atmosphere, exo-atmospheric, engaging ballistic missiles in space during the upper portion of their trajectory. Arrow 3 uses hit-to-kill technology, meaning it destroys its target by colliding with it at high speeds. The interceptor's range extends to 2,400 kilometers, providing defense against missiles that could potentially carry weapons of mass destruction. Arrow 3's ability to operate in space also allows it to potentially serve as an anti-satellite weapon. The Green Pine radar and other advanced radar systems are responsible for early detection of incoming threats. These systems track the trajectory of missiles from launch and provide real-time data to the Battle Management Center. The Citron Tree Battle Management System integrates data from radars, controls the launchers, and assigns interceptors to targets. This allows the system to rapidly assess the threat and determine the best defensive action. Both Arrow 2 and 3 are deployed from mobile launchers, providing flexibility and the ability to cover large areas. Each launcher can hold multiple interceptors, allowing it to respond to several threats simultaneously. This concludes our episode that provides a glimpse into Israel's air defense system. So, what do you think about this technology? What other pieces of military hardware would you like us to cover in our future episodes? Also, if you are lucky enough to see this system up close, or better yet, operated one, please comment. Remember to hit the subscribe button and ring that bell to stay updated with our latest content. And while you're here, why not check out another one of our exciting videos? Thanks for watching, and see you in the next one.